Hello everyone, my name is Scott, and in this series I'm going to be going through all the LeetCode.com problems. Yes, all 2,060 of them at some point. I will start with the easier ones to learn core concepts and build from there. The first problem we're going to look at is twosum. So twosum states, given an array of integers called nums and an integer called target, we're going to return the indices of the two numbers that add up to target. Now we may assume that each input has exactly one solution and we cannot use the same element twice. So let's look at the three examples they gave us. In the first example, the values that add up to 9 are 2 and 7. So those are at index 0 and index 1. So the output is 0, 1. In the second example, the 2 and the 4 add to 6. And so we're going to return index 1 and index 2. And in the final example, we have 3 and 3, and because we have both of those numbers, we can use them twice, and the output is 0 and 1. Alright, so let's go to my favorite part of the segment, which is called the pseudocode. So LeetCode gives us the method and the input parameters. The first thing we need to do is define a bucket to hold each number and its place in the array. Then we're going to loop through each number in the array of numbers. We're going to subtract each number from the target number, and we're going to store this value in a new variable, which I'm going to call the buddy number, at least for the pseudocode. Now we need to find out if this bucket has that buddy number. If so, we return the buddy number's index as well as the current value of each number's index, and we're done. Otherwise, we need to put each number and its index in the bucket for future use. Then we end the loop, and if there isn't a solution, we return nothing, and then we end the method. So one of the things we need to be concerned about is how are we going to keep track of these numbers and their indices? Well, we're going to use what's called a HashMap. HashMap will store the key value pair, and we'll keep those two together. There's three methods we need to use with the HashMap, the first one being the put. So we need to be able to put numbers into the HashMap. Syntax is fairly straightforward, just going to put the key and the value, and the HashMap will keep those two values together. Next, we're going to use the get method. So we need to be able to get values out of the HashMap. So we're going to pass in the key, and it will return the value. And finally, we don't actually want to call the get method until we know there's a value in there. You can call it, it'll return null, but there's no need to if it doesn't contain the key. So we use the contains key method, pass in the key, and it will return true or false. Alright, so let's code it. Here's the method that LeetCode gives us. First thing I'm going to do is define that HashMap. Both nums and target variables are integers, so we can define integer, integer, and I'll call it map and instantiate it. Okay, now we're going to loop through and assign the initial value to 0 because arrays are 0 based, and we'll make sure it's the num's length. I is less than num's length. Okay, so we're going to take the target minus the current value of nums and assign that into complement. I guess I won't call it the buddy number. If the map contains this key, then we're done. We're going to return the new int, and this time we'll get the key, which will return the value, and the current value of I. Otherwise, we're just going to put the value of nums and the value of I, the index, into the HashMap for future use. And that's pretty much it. Now, we'll return null because this method is looking for some type of return, and this return is scoped to the for loop. And then we'll end the method. Alright, so let's go to IntelliJ and debug this. So I picked the second example that LeetCode gave us, the 3, 2, and 4. So we'll start by going through, looping through nums. So the first thing it's going to do is take 6 minus 3. So the complement will be 3. Does the map contain 3? No, we just started this. There's nothing in there. So we're going to put 3 and index 0 into the HashMap. So if you look down here on the HashMap, you see 3 and 0. Continuing onward, we're going to take the target 6 minus 2 in this case. Does the map contain this value? No. So we're going to put 2 and 1 into the hash map. So if you look down here on the map, you see now we have 3, 0, and 2, 1. All right, third time's a charm here. So we take target 6 minus 4, which is 2. Does the map contain 2? Absolutely. Winner, winner, chicken dinner. So we're going to return a new int, and we're going to get the complement. So we're going to pass in the key, and which will return the value, and then we'll return the current value of I. And so if you look at this result, 1, 2, which is the result we're looking for. All right, now let's submit this in LeetCode and see what happens. Look at that, accepted. We'll submit it. Ooh, 79.1, I'll take it. So there we have it. The last thing I want to go through is the space and time complexity. So time complexity measures the amount of time it takes to run the algorithm. So the only way that this algorithm is going to take longer to run is if the passed-in array has more elements in it, more numbers in it. And so this, we write this as big O of n. And you can see down here in the graph that as n increases, the execution time increases in a linear fashion. And so this is what's called linear complexity. Now we're only talking microseconds here, but as the program gets larger, these start to add up. Now the space complexity measures the total amount of memory that an algorithm or operation needs to run. Now this is also O of n, because the only way you're going to use more space is if you have more numbers in the array. And again, this, as n goes up, the memory used goes up. And this is also in a linear fashion. Okay, well that's it. Let me know your thoughts in the comments. Please be gentle. This is my first video. And now we only have 2,059 of these to go through. So good luck in your interviews, and hey, thanks for watching.